right, so we had just completed our sine graph over here. Remember that anywhere your function is positive, that you are, when you're doing absolute value, you're going to get exactly what you started with. But anywhere what's inside the absolute value is negative, you're going to get the opposite of what you started with. So for us, our function t squared minus 5t plus 4 is positive here, so I would use this exact equation from negative infinity to 1. Then it's negative from 1 to 4, so I would use the opposite of this equation from 1 to 4. And then from 4 to infinity, it's positive again, so again I would use this exact equation. So for our problem, we were going from 1 to 5, okay? So from 1 to 4, it's negative. I'm going to use the opposite. And from 4 to 5, it's positive. I'm going to use the original function. So you can see over here from 1 to 4, we used the opposite. And then from 4 to 5, we used the original function. So all we needed to do with that one was just set it up because we've already demonstrated our ability to do the integration in the previous problems. All right, then the last thing that we want to look at is average value of a function. All right, so for average value of a function, again, we are still doing our normal integration. The only difference is that we're going to do 1 over b minus a times that value that we get from the definite integral. So they gave us this function and they gave us this interval. So let's start with 1 over b minus a. That would be 1 over 3 minus 1. So 1 over 3 minus 1 is going to give us 1/2. So whatever value we get from this definite integral, we're going to multiply it by 1/2. Okay, so now let's evaluate our definite integral. I do not have a quotient rule. So I'm going to have to find a way to rewrite this without the quotient. So I'm going to break it apart into separate pieces, and then I can simplify each of these pieces. So x cubed divided by x squared is just going to leave me with x, so 2x. And then x squared divided by x squared is going to leave me with 1. And then 3 over x squared, I can move that x squared up to the top with a negative exponent, so that would be 3x to the negative 2. So I haven't taken the antiderivative yet. All I've done is simplify it into a form where I can. So the antiderivative of 2x to the first, I'm going to add 1 to that exponent, so that would be 2x to the second, and divide by that same number 2. Antiderivative of 1 would be 1x over 1. And the antiderivative of 3x to the negative 2, if I add 1 to that, that would be negative 1, and then divide by that same number. So our 2's will drop out here and just give us x squared plus x, and then minus 3x to the negative 1, or minus 3 over x. Either way you want to write that. So let's plug in our 3 to begin with. So we're going to do plug in b and then plug in a. So if we plug in 3, we're going to get 3 squared is 9 plus 3 minus 3 over 3, 1. So 9 plus 3 minus 1. So 9 plus 3 minus 1. Then we're going to subtract from that 1 plugged in. So if we plug in 1, that's going to be 1 plus 1 minus 3. So 1 plus 1 minus 3. So 9 plus 3 minus 1 is going to give us 11. And then 1 plus 1 minus 3 is going to give us negative 1. 11 minus a negative 1 would be 12. So that's the value of our definite integral. And then for the average value, we do the 1 over b minus a, 1/2 times 12, and that gives us the average value of our function, which is 6.